Welcome back to video series on understanding structural behavior. Have you ever wondered why bridge cables curve so elegantly, or how they support the load of vehicles and pedestrians so effortlessly each day? Today I will explain you why. In this video, I will walk you through a clear step-by-step process to analyze cables in bridge engineering and suspended structures. I will solve 4 examples and you will find timestamps in the description down below, so feel free to jump around as this session is going to be longer than usual today. This is part of my video series on IStructE certificate in structural behavior. If you want to understand basic behavior of structures, this video series is for you, and here I will solve 4 examples. These are the 4 examples that I will look at. The first one has got uniformly distributed load and the supports are at different level. In the second one, you have uniformly distributed load, but it is just partly applied on one part of the structure. In the third one, you have off-center point load and uniformly distributed load, and we will see how we can handle this kind of situation. And in the fourth one, you have uniformly distributed load, and also you have a point load, but the point load is nearer to the right side. And here we will try to find out the tension forces, horizontal reactions and vertical reactions, and values of dip or sag as well. First example is related to this cable structure where the cable dips 1 meter below the left support at 3.66 meter and from the left hand support horizontally. What is the maximum tension in the cable? And there are 4 options to choose from. And it's very difficult to say until you do some simple calculations to find out the maximum tension. I strongly suggest that you try this question first, pause this video now and follow these steps. So the things that you need to consider, that this cable is pinned at both ends, and horizontal component of tension, it always remains constant throughout the cable. The maximum tension happens where you have vertical component that is maximum. There are 3 things that you have to keep in mind. L1 over L2, this is L1, this is L2, is equal to square root of H1 over H2. This is the formula which comes from parabolic curve of cables, and there is a derivation, and please have a look at another video which I created earlier. It has got all the details and I will show you where I got this formula from. Earlier I talked about this formula where Z over H is equal to X square over L square, or you can say that under root of Z over H is equal to X over L. Here I'm calling this as L1 and L2, and here I'm calling Z and H as H1 and H2. So use this formula to find out this unknown length X, and vertical reaction is equal to UDL times the distance from support, and find the horizontal reaction using rotational equilibrium at supports. You can take this quiz by scanning this barcode or going to this URL. Link will be down in the description. Try this question first. Pause this video now before proceeding further. So let us get started with the first question. I call these values as H1 and H2. H2 is 3, a summation of 2 and 1, and H1 is equal to 1. So when I put these values over here, you have L1 equal to 3.66 and L2 is equal to 6, 1 over 3, and from here we get value of X as 6.34. Once we have got this value, then it will make our life easier. We will be able to find other values as well. Vertical reaction now is equal to UDL times distance from the maximum dip. So here I have labeled these as A and B, and the center point is C. H is horizontal reaction, VB and VA are vertical reactions. So VA is equal to load up to this point, which is 10 kilonewton per meter, times the distance. So 10 times 3.6, it will give me 36.6 kilonewton. On the other hand, for right side, simply it's UDL up to this point, and distance between B and C. Distance between B and C is 6.34, and from here we get value of reaction as 63.4 kilonewton. So far so good. We've got the reactions right. Let's move to our third and final step, where we will use rotational equilibrium at supports. The reactions we found out a bit earlier. We say that summation of moment at A is equal to 0 at this point. Here VB is vertical. It is causing anti-clockwise rotation with respect to B, so that's why it is negative. And distance between A and B, this distance is equal to 10 meters, so that's why you have 10 over here. HB times 2, HB is this value, and distance from point A to B, the vertical one, is 2, so that's why you have got 2 over here, and this is creating a clockwise moment. And then you have this load 10. The total load is 10 times 10, and it is half of the distance away, which is 5 meters, so that's what we have done over here. And from here we get HB as 67 kilonewton. Now we can say summation of moment at B is equal to 0 and find HA. But as you know that horizontal reaction is same throughout the cable, so there is no need for this step. So this is just for checking that if it is right or not. So here HA is 67, HB is 67, but this is extra step, so you don't actually have to do this. As you know that the maximum tension happens at a point where you have maximum vertical reaction. Here maximum vertical reaction is at B, so it is understandable that we will have maximum tension force over there. So horizontal remains the same. At B we have vertical reaction is 63.4. Under root we are finding resultant force, and from here we get 92.9 kilonewton. And using the same logic we find out the tension force at A, where we have horizontal reaction which is same, and the vertical reaction is different, which is 36.6. Here we get a small one, so maximum tension is 92.2. So our answer is 92.2, which is option D. Tell me, did you get it right? Do not worry if you did not. You can always watch back this tutorial. And now it's time for me to move to the next question, because I have to solve 3 more questions. This is the second example. The weightless cable is loaded on one side only and sags as shown. If the dip is 1.6, what is the maximum dip in the cable? And you have to choose from 4 options: 1.7, 1.75, 1.8, 1.65. I suggest that you try this question first with the help of these steps and see if you get it right. Pause this video now after I explain you the steps and solve it yourself before watching the tutorial. So again, these rules, first 3 rules are same. Cable is pin supported at both ends, tension remains constant, and third one is that maximum tension happens where vertical load is maximum. So first you have to find out vertical reactions using equilibrium equations, and secondly you have to take a cut at the central point, which is this point. Then cut the maximum dip point and use equilibrium to find max dip, and then we have to cut at this point. We call it as Z point. In that way you'll be able to solve this question fully. Try this quiz as well and see what answer you're getting, and put the answer in the comments down below. scan this barcode or go to this URL. The links will be down in description as well. I will wait for you when you solve this question and you come back to start the video from here. So first step is to find the vertical reactions. These are the notations: horizontal reactions, vertical reactions. These are the horizontal one, the vertical ones, and distance x. Central point is denoted by C, and this is Z. So first we say that total vertical reactions are equal to 8 times 5, which is 40, and then we say summation of moment at A is equal to 0. From here we say VB times 10. VB is this one, and the distance between A and B is 10. That is equal to 8 times 5, that is this load, and it is acting at 7.5 meters away from B. So 5 over 2 plus 5 is 7.5. From here we can work out value of VB. So VB is 30, and if we put it back in here, you will get value of VA as 10 kilonewton. Once we have got the reactions, then we are ready to go to our next step. The next step is to cut at the central point to find the horizontal reaction. So we have cut it over here at this point, and we say that summation of moment at C is equal to 0, and we are now taking only the left part. And the reason we are able to do it, because here at any point in the cable the moment is going to be 0. Otherwise, if it was any other structure, we won't be able to do it in the middle portion. We have to take both sides. We can't isolate it. So here we are isolating this point and taking only the left part. So 10 times 5, 10 is VA. This is creating a clockwise moment, and then I have HA times 1.6. This is creating anti-clockwise moment, and this is equal to 0. I have no other forces at left. From here I can work out value of HA is 31.25. Now if you work out HB by taking the right side, still you will get the same answer HB, but for HB you will have to cut at the maximum point where that portion, entire portion, is sagging, and this maximum point where it's sagging is Z. So you have to cut it at Z to get HP, but the horizontal reactions are going to be same. Then finally we have to cut at the maximum point and use equilibrium equations to find the maximum dip. Now maximum point was Z, and we call maximum dip as H. VB is 30, HA, HB is known to us as well. So using vertical equilibrium, we can say that 8 load times the distance 8x, x is not known to us, is equal to 30 kilonewton, which is the reaction. So from here we can easily find out value of x as 3.75 meters. And then we say that summation of moment at Z equal to 0. So moment at Z equal to Z is this point. We have first of all the UDL. So 8 is UDL times distance. Distance was 3.75 times it is acting at half of the distance, and it's creating a clockwise moment. So this is a clockwise moment, that's the reason it's positive, and minus VB times 3.75 plus HB. HB is creating a clockwise moment, so that's why it is positive. When we put all the values, we can get value of H as 1.8 maximum dip. So maximum dip is 1.8 meters. Now tell me, did you get this right? So correct answer is option C, which is 1.8 meter. Just check that if you got it right or not. If you haven't, then watch back this tutorial, download the lecture notes, and have a look at how it is solved. Let's now move to our third example. In this example, we not only have a uniformly distributed load, but we have a point load as well, and cross-sectional area of cable is given, which is 500 millimeters square. So what is the maximum tensile stress? This time it's asking us stress. Now there are 4 options to choose from, and we will see which option is correct. But before you watch this tutorial for third example, solve this question yourself. Here we have cross-sectional area 500 millimeters square and horizontal tension remains constant. Where vertical component is maximum, you will have maximum tension. First, you have to determine the vertical reaction. This is the first step. Second step is cut at cable's lowest point to find horizontal reaction. So we have to cut at the lowest point, which I think will be this point. And then we have to determine maximum force and find maximum stress. These are 3 steps. I will exactly follow these 3 steps to solve this question. If you follow these steps and try this question first, pause this video now and see if you can solve it. Take this quiz before watching the tutorial. Scan this barcode or go to this URL. The link will be down in description as well. Before I go to solution, tell me what answer did you get. Just put it down in the comments. Let us first of all find out the reaction. So we have this structure. We have HP. This is HP, not VB. HB and HA and VB and VA. From here we say that total load VA is total load divided by 2. So 12 times 17 divided by 2. This is due to UDL. And for point load, I'm using this formula: load times off span divided by full span. When you have off center point load, then reaction is equal to load times off span divided by full span. So full span is 17, load is 90, off span means this distance, which is 10, and from here I get value of VA as 154.94. The total load VA plus VB is equal to UDL 12 times 17 plus point load, which is 90, so it is 294. So if I subtract this value 154 from 294, I will get 139, which is value for vertical reaction at B. Let's do step 2 and 3. We have to cut at the lowest point to find the horizontal reaction. So let us cut at C, and here we say that the summation of moment at C is equal to 0. So 159 times 7, this is the reaction times 7. It is clockwise moment, so that's why it's positive. And the load itself, this load is creating anti-clockwise moment. So 12 times 7 times 7 over 2, and then we have HA times 3 meters. So this dip is 3 meters, so that's why we have divided it by 3, and from here we get value of HA is 263.5. The value of HB will be the same as well, but the maximum force in the cable will be at a point where you have maximum reaction. So maximum reaction is at A. This is not point C, this is actually point A. And once I have these two forces, then I will say under root horizontal square plus vertical square. It will give me force of 305.7 kilonewton. And from here I can find out stress. Stress is equal to force over area. I've converted this force into newtons, divided by area is 500. From here I get 611.4. Let us see what option matches closely with this answer. The correct option is 612, which is option D. Did you get this right? There is no need to be concerned about. You can always watch back this tutorial or have a look at the lecture notes. Let's now move to our fourth and final example, which says the hanging cable deflects as shown. What are the horizontal reactions at supports? In fact, both horizontal reactions are going to be the same. So there are 4 options to choose from, and to solve these questions I will give you step-by-step process so that you can solve it yourself without even looking at this video tutorial. So here, these are the constant things that I mentioned earlier. There are 3 steps here. Find vertical reactions by equilibrium, and not 3 steps, 2 steps, and take moment at a cut through the cable's lowest point and find the horizontal reaction. I suggest that you try this question first using the steps which I mentioned. Scan this barcode, go to this URL, links will be down in the description as well, and see which option is correct. So choose the correct option and put the option down in the comments. Let's start with our first step, which is finding the reactions. So reactions will be due to UDL, load times length divided by 2, and here for A I will use load times off span divided by full span. So load is 18, off span is span that is away from A is 2, divided by full span is 6. That is the formula that we use for off-center point loads. From here we get VA as 21. Now again I use the same logic for VB. UDL remains the same, total load 5 times 6 divided by 2. Load times off span, now off span is 4. So 18 times 4 divided by 6. This is giving me 27 kilonewton at B. A 21, B 27. The next step is to find the horizontal reaction by taking moment at the cable's lowest point. Lowest point is C, and here we have to take summation of moment at C is equal to 0. So minus 27 times 2, this is creating anti-clockwise moment, so that's the reason it is negative. And then load, this is 5 kilonewton per meter times 2 times 2 by 2 is 1. This is UDL creating a clockwise moment, and then HB is creating clockwise moment as well. So HB times this 2. From here we get horizontal reaction as 22 at B. At A it will be same as well. That will be 22 kilonewton. As you know that horizontal reaction remains the same throughout the length of the cable. So I think that's our answer. We have finished. So option B is the correct option. I hope that by this time you would have got it right, because this was the 4th example. The references which I've used for this lecture is this Examples in Structural Analysis by Mackenzie. I've not specifically used this book for these examples. I've taken these examples from IStructE certificate in structural behavior practice questions. If you want to know more about structural behavior, or if you're preparing for IStructE certificate in structural behavior, this video series will be very useful for you. Scan this barcode or go to this URL to watch more videos like this. Also, you can download the copy of lecture notes by going to this URL or scan this barcode. Links will be down in description as well. Thanks for watching this tutorial today. If you have any feedback or any comments or any questions, put them down in comments below. If you found this video useful, share it with your friends, like it, and consider subscribing if you find videos useful.